I'll keep this simple. Manufacturing is hitting an arc to AI moment, from the torch to the toolpath to the tensor. The stack is getting smarter: aerospace, automotive, sustainable engineering. On the arc side, GTAW isn't just steady TIG anymore. Pulse modified, hot wire, keyhole, hybrid TIG laser, deeper penetration, faster deposition, cleaner microstructures. Optimize pulse frequency and duty cycle. Add real-time sensors, dialing in grain size and defect rates on the fly. On the machining floor, composites used to mean frayed edges and burned resin, laser and abrasive water jet, ultrasonic and EDM, diamond-coated tools and AL-CRN-coated tools, cryogenic cooling and MQL, hybrid assistance drops, forces, wear, and delamination. Materials are leveling up too: automated fiber placement and additive manufacturing, CNTs, graphene, MXenes, strength, conductivity, thermal performance, if dispersion and orientation are right. Alloys aren't sitting still: microalloying and nanoprecipitates. AI watches the pool: vision, acoustics, thermal data, spotting defects and adapting parameters in real time. And yes, sustainability matters. Natural polymer-based composites are moving from lab to line, in homogeneity and low thermal resistance. Ultrasonic bonding, friction stir bonding, and smarter drill geometries are closing the gap. Here's the headline: integration wins. Hybrid welding, non-conventional machining, advanced composites, wrapped in AI-driven control, is the new playbook. What I'm watching next: unified sensor fusion across welding and machining, scalable hybrid manufacturing for dissimilar materials, and design for AI. Parts, tools, and parameters co-optimized from day one. If you're building the next-gen shop, start small. Instrument one process, train one model, optimize one parameter set, then stack the wins. The future factory is adaptive, data native, and materials smart. And it's closer than it looks.